to do the, so it's doable.
Okay. I think all of us, almost all of us, like 16 people, maybe they're coming in also. We are online. I'll share the screen. And let's do our lecture. Can you see the right corner of my screen also, the place that I have graph in it?
Yeah.
Can you see the graph fully?
Wait, I need to move the window of your guys' faces out of the way. There we go. Yep, right there.
My window, my Zoom window will not stopping you from seeing it, right? Because you see the page, not my screen, right? Can you see it?
Yep, now I can.
Yes.
Here.
Oh,
Okay, today 10.3 polar coordinates, a topic that maybe new for some of you, and maybe some of you had it before. I don't think so about all the students of MSJC that they could cover this topic in pre-calculus. I don't know if you covered it or not. But those of you that you came directly from high school to this class, or you had a math class in high school, maybe they covered for you this topic in trigonometry. I have no idea who knows this topic a little bit, or maybe it's totally new for you. But anyway, I will start it from the beginning, because in your book, we do a quick review. We do a quick review on polar, then we go and discuss the calculus of polar coordinates. Let's start with polar coordinates. What is polar coordinates? Polar coordinates is a system like this that you see in my screen. This system actually introduced by Sir Isaac Newton. He introduced this system to us. And what does it mean? I'm going to explain to you what does it mean and what is the polar system. Before polar system, right now, I think everyone is very good with this system, which we call it the rectangular or the Cartesian coordinate system, right? We call this one the Cartesian coordinate system, and you learn it from beginning of algebra up to now. Every day you are dealing with this system and you know every characteristic of this system. For example, if I put a question, if I ask you, okay, I have here a point, correct? And I'll name this point P. If I ask you, what is the sign of X and Y in this quadrant? All of you, you're aware and you know it by heart that X is positive, Y is positive in quadrant 1. Correct? We call this one quadrant 2, and we know X is negative, Y is positive. And we call this one quadrant 3, and we know X is negative and Y is negative. And we call this one quadrant 4. We know X is positive, Y is what? Negative. Now, the new system that you see here, we call this one polar coordinates. What is polar coordinates? I will start introducing the polar coordinates this way for you. For example, the screen, my whiteboard is a plane, right? First, you choose a point in your plane. The name of this point, we call it pole, which means actually origin. After that, you are drawing a ray on the right side of this point. This is a ray, right? You are drawing always on the right side, on the positive side of your pole, correct? We call this one polar coordinate or polar axis. Now, if I choose a point P here, and I connect this point to my pole, which is origin, right? It's a point P. It actually creates an angle for me. Let's name this angle, for example, the famous guy theta. Now, if I ask you, and you see this P has a distance from your pole or your origin, right? It has a length, a distance. Let's name this one R. Correct? Now, if I ask you, what is the coordinates of point P? Can you tell me what is the coordinates of point P now?
Yeah,
Uh-huh.
you would have to have the length of the X on the bottom of the ray.
Uh-huh.
And you have to have the height of the triangle. So
Yes, it's in Cartesian, but when you come to polar, your first coordinates is always this length, the distance from the origin or from pole. Your second coordinates, instead of having y, you get an angle here. It means in Cartesian, you had xy. You see, I draw it even for you. It's not even showing in your book. In Cartesian, a point has a coordinates of xy. It means the distance from x, the distance from y. In polar, you have a coordinates of r and theta, or angle. It means the distance of the point from the pole or origin, and also this angle theta. If you see the right side, I brought this graph paper, I cut and paste, and you need to find this graph easily. You can find it from internet. Just type polar graphing paper. There are many types of them. You can print at home and you can have it because now you need. It gives you a graph like this, correct? Which is kind of circular, you see, and you're dealing with different angles. Now, theta, let me put all those notes for you. Theta is your angle. R is distance of P from pole or origin. What else? P is a point, any point. And that's it. These are the new things that you have to know. What is P, what is theta, what is angle? Now, few things. Maybe most of you, you know this part. If I wanna draw this, my ray, that's a pole. If I wanna draw a positive angle, which is the first or maybe second topic in trigonometry, everyone knows what is a positive angle. It means when your theta is positive. What does it mean? Who knows what does it mean when theta is positive? If you want to draw a positive angle, what will you do?
it's going like counterclockwise.
Very good, excellent. Positive angles, you are moving counterclockwise, right? You are going this way. Positive angles always counter If I do a spelling mistake, don't tell me, otherwise I'll deduct your point during the test, okay? Positive angle means you're moving counterclockwise. It gives you a positive angle. Negative angle, if your theta is negative, you are going what? Definitely clockwise. If I draw another angle for you, if I go this way, from here to here, it's a negative angle. Any question up to this point? Any question for me? Yes, no? Okay. Now, if your R is positive, I will write this way. If R is greater than 0, what does it mean? Here is the pole, here is my ray. For example, when you draw a positive angle here, this is theta, theta is positive. When R is greater than 0, it means you are here. This is your R. When R is less than 0, how to find R less than 0? This is your pole. For example, first you have to find your point. This is my point P. And this will be R, but you are looking for the negative R. What you do, you continue this way in a straight line, 180 degree, and take this distance. How much is this distance? Reflected to the other side of your pole, it gives you your R as a negative R. Again, maybe your angle is positive, correct? These are the basics. Now I'll do a few examples. These are a very, very basic lecture how to deal with the polar coordinate system. One more thing that you see here, I am using an arrow, but here I close it. It means this is a line segment. It has a starting point and it has a terminating point, which we call it the terminal, correct? Let's do some examples. Let me bring that graph down and let's do some examples and let's practice. Example number 1. Let's start with basics. Example number 1, for example, if I ask you to find this point, 1, 2 pi over 3, plot this point on the system. First, is this the value of X and value of Y, or it's different? What is 1?
A number.
R.
1 is always showing your what? Radius. You see, I put like this, P, R, theta. Your coordinates is now R and theta. 1 is your R. 2 pi over 3 is your theta, right? Can you see this graph very well, or you want me to make it kind of bigger for you? Can you see it now very well?
That's good.
It's big, right?
Yes.
Okay, can you see it now? It was 1, 2 pi over 3, the point that they're asking you to find. You see the circles? The first one shows 1. The second one shows 2. The third one, 3, 4, 5, 6, 7. Here I have 8 of them, up to 8. It can be up to 100. Like in x-axis, you have 1, 2, 3, 4, 5, 6. But here we draw circles, correct? Now, 1 and 2 pi over 3. Where is 2 pi over 3? Can you find 2 pi over 3 for me? Where is 2 pi over 3? Here. 2 pi over 3 and 1. I'll mark here. This is my point. Here is my point. Did you get it? How? 1 or, sorry, it's 2. Oh my God.
I was confused for a sec.
Let me go to 1 because it's too small. 1 and 2 pi over 3 is actually this point. Your distance of R from the pole is 1 and your angle is how much? 2 pi over 3. Easy, difficult? It's easy to find a point, right? Let's do one more. For example, 3 and let's say pi over 4. It means 3 circles, your R is 3, and the angle is pi over 4. Where is my pi over 4? Here is your pi over 4. Pi over 4 and 1, 2, 3, hopefully here, right? My eyes are kind of moving, even I cannot count. 1, 2, 3, yes. 3 and pi over 4 is here. That's your point P, correct? P, 3 and pi over 4. If I ask you find -2 and pi over 3. Now, where is -2 and pi over 3? First, you have to find your pi over 3. Where is pi over 3?
At 60 degrees.
At 60 degrees. This is your pi over 3. How much is the value of R? Your R is -2. Actually, you can't be on this side. You see. How to find that point? This graph is actually help you a lot. Even you don't need to reflect. Look, pi over 3, go to the other side of pi over 3. It's a straight line that you can see here, and 2. This is actually -2 and pi over 3. I am on pi over 3. The +2 will be here. When you reflect, it comes to this side, correct? Please, when you label, do not use this angle. Do not use 4 pi over 3, whatever it's given to you. This one is -2 and pi over what? 3.
You put on the third one though, but yeah.
On the third one, sorry, this one too. I'm using glasses, right? It's really difficult for here. Correct now? 2 and -2 and pi over 3. There are a few examples in your book on page 699. There are many of them that you can see how you plot a point. Any question? Yes, no?
No.
Okay. Now, the next topic, there is a relation between the polar and Cartesian. Remember the day that I was talking about the, what we call it, the, it was inverse trigonometric functions when I was talking about hyperbolic trigonometric functions, right? I did a proof for you, even I show the relation between the Cartesian and polar on that time, but I'll go over that again, right? Let me draw first the Cartesian coordinate system. Here X, let's name here Y, correct? If I draw here an angle, and here I'll stop. This angle is, for example, theta. Of course, this point in Cartesian has a coordinates of pxy, right? The distance of this point from here, x, the distance of from here, y. Now, and this is of course your r. If I ask you to write these trigonometric functions for me, can you do that? If I ask you, what is sine of theta? What is cosine of theta? And what is tangent of theta? What is sine of theta?
X over R.
Yes. X over what? R. Because we see right now you are dealing with this triangle. This is your Y. This is your X, right? Then X over Y over R is what? Your sine theta. What is cosine of theta? X over what? X over R. And what is tan theta? Tan theta is Y over what? Y over X. I don't think so that you have a problem here, right? At least you remember this much from trigonometry. Also, let me put here this for you. R squared equals x squared plus y squared. What is this? R squared equals x squared plus y squared?
Pythagorean theorem.
Yes, Pythagorean theorem, right? Let's keep these two separate. Let's work first with these two. From this equation that I have sine theta equals y over r. If I ask you to solve this equation for y, can you solve this equation for y for me? What is y equal to?
Sine X.
R times sine theta, right? Because you multiply both sides by r to solve it for y. Then from here you can say y equals r sine theta. And from here, x equals r cosine theta. Let's put these two in a box. Y equal r sine theta, x equal r cosine theta. Now, when it means, what does it mean? It means here in this picture, the coordinates of point P in Cartesian is x and y. In polar, it will be r and what? Theta. Correct? Now, we talk a little bit, let's talk a little bit about converting example one. For example, converting the polar, the polar coordinates to Cartesian. How to convert a polar coordinate to Cartesian? For example, they give you this polar coordinates. Convert 4 and pi over 6 to Cartesian coordinates, right? I know 4 comma pi over 6 is polar because the first number is r, the second number represents theta. I'm encouraging you to first find the position of this point in polar. It helps you a lot. 4 and pi over 6. Where is pi over 6? Pi over 6 in your graph is somewhere here, right? 30 degree. For example, these dots are showing my circles. I cannot draw good circles here for you. I'll just put the dots here. And this is my 30 degree. Then this is 4 comma pi over 6 or 30 degree. It means r is equal 4. R is 4. And this angle is pi over what? Pi over 6. Now, how to convert? Should I say it's really difficult or should I say it's really easy? Look, you have to always remember, always when you convert from polar to Cartesian, use these two. That's why I put a line there. That's why I separate them. When you are converting from polar to Cartesian, use these two formulas. I have x equals r cosine theta, and I have y equal r sine theta. Do I know how much is r here?
Yes.
Then x equals 4 cosine of pi over 6. My theta is pi over 6. Then x equals 4. What is cosine of pi over 6? How much is cosine of pi over 6?
Radical 3 over 2.
Very good. Radical 3 over what? Over 2. I can cancel out, I can simplify by 2, then x equals 2 radical 3. Same way, y equals, how much is r? R is 4. Sine of theta, theta is pi over 6, which is y equal 4 times sine of pi over 6, 1/2. It means y equal what? 2. Now you see you change actually your polar coordinates to Cartesian. It means your x is 2 radical 3 and your y is what? 2. Easy, difficult? Easy? Let's do one more. Again, convert. Negative radical 2, comma, pi over 4. First thing, you have to find where is negative radical 2 and pi over 4. If I ask you even before drawing, which quadrant you are now?
You're on the second.
You are on the second in Cartesian, but in polar, you cannot say which quadrant you are because you will draw this way, okay? Here, my point, this is x, pi over 4. Pi over 4 is 45, right? It's a point here that the distance on this side will be radical 2, and this is pi over what? Pi over 4. To find negative radical 2, you have to reflect to this side. Here is your negative radical 2 and pi over 4. Now, I want to convert this one to Cartesian. Then x equals r cosine theta. It means x equals r negative radical 2 cosine of pi over 4. It means x equals negative radical 2 times cosine of pi over 4.
Radical 2 over 2.
Radical 2 over what? 2. Which gives you x equals negative 2 over 2, which gives you what? Negative 1. Y equals r sine theta. It means y equals negative radical 2 sine of pi over 4. It means y equals negative 2 times sine of pi over 4 is also radical 2 over what? 2, which gives you what? Again, negative 1. It means the Cartesian coordinate of this polar point is actually 1 comma what? Negative 1. Any question? Any question for me?
No, I think they're both -1 though.
Negative 1, sorry, not 1. Negative 1, negative. Now, opposite. They give you a Cartesian coordinates of a point and they are asking you to find the polar coordinates of it. For example, they give you 1 comma negative 1. They are asking you to find the polar coordinates of this point. Let's go a little bit back up. To change Cartesian to polar, use these two always. You have tangent of theta equals y over x, and r square equals x squared plus y squared, correct? Now, I have r squared equals x squared plus y squared. Step 1. First, find the value of r. You see, I have r squared equals x squared plus y squared. On the other side, you have x equals r cosine theta and y equals r sine theta. If I solve this equation, be careful here, this is the tricky part. If you solve this equation, x equal r cosine theta for r, right? I'm sorry, we don't need this. Keep this. Do not solve it for this problem. Okay, r squared equals x squared plus y squared. and you are in Cartesian system. Is this the value of X? Is this the value of Y? Agree?
Yes.
Then I can write R squared equals 1 squared plus negative 1 squared. It means R squared equals 1 plus 1. It means R squared equals 2. If you take the square root from both sides, the square root of R squared equals plus minus a square root of 2. Here, R equals plus minus a square root of 2. But should I use the positive or negative R? This is how you find to use positive R or negative R. Look, your point is given as a 1, negative 1, and I know 1, negative 1 is here. I'm in quadrant 4. The value of X positive, the value of Y negative, correct? It means here I will use positive radical 2, not negative, correct? This is the value of R. Now, I have to find theta. I have tan theta equals X over Y. I have the value of X, I have the value of Y. It means I can say tan theta equals X. How much is your X? The X is given to you, 1. Over Y, negative 1. It means tan theta equals negative 1. If tangent of theta is negative 1, the tangent of which angle is negative 1? Even you can use your calculator. Look for the inverse tan button in your calculator, and easily you can give me the angle. Which angle is that?
3 pi over 4.
Pi over 4, because you have a negative pi over what? Negative pi over 4. Now, what are the possible coordinates? Your possible coordinate is your R, which was radical 2, comma theta, negative pi over 4. Do I have only one solution, one solution, or I can have many solutions here, many points at the same coordinates? You see, because you are dealing with angle, there are many other angles that they have the same tangent. For example, the other one will be 7 pi over 4, right? If you see the tangent of 7 pi over 4, it's also negative 1. There are many of them. But because I choose my radical, my R as a positive radical 2, I'll just stick with this answer and I say, okay, the polar coordinates of the given point is radical 2 and pi over 4.
I have a question.
Uh-huh.
So why are we using tan here?
Because you know tangent is X over Y. And if I give you a coordinates in Cartesian you have always like this, yeah?
Isn't tangent y over x?
Tangent is Y over X.
Yeah.
Yeah. What I put? Wait a
Correct.
minute. Surprise for a minute. Anyway, I'm lucky that it's negative 1.
Yeah, I was going to say we're lucky that the answer was going to be the same
answer.
regardless.
Y over X, not X over Y. Correct? That's why the reason you are using tangent, because if you give you the Cartesian, it's always coming as an order pair of X, Y, right? And your tangent is always Y over what? Over X.
So if we use the x and the y, we would just get two numbers, but we wouldn't get the angle for the second part for the y. So that's why we're using tan.
That's why you are using tan to find the value of r, because you see the relation r squared is equal x squared plus y squared. And if I give you a Cartesian like this, 2, 4, right? You know how much is x, how much is y, you can find your r. And after that, y tangent, because always if I ask you to change to polar, I give you a Cartesian coordinates. It means I always gives you x and y. That's why you see in tangent, it's always y over x. That's why you are using tangent.
Okay, thank you.
Let's do another one. Try for a minute. For example, another one. (3, -4). We change it to polar. Try and find r for me. R equals square root of x squared plus y squared.
Okay.
Even you can use this one. How much is your r? 5? Now, tan theta equals always y over x. It means tan theta equals y -4 over 3. In some problems, I told you, if you use your calculator, if you use this button, inverse tan, it gives you an angle. But even if I ask you, okay, what is theta here? You can write this way. My theta is inverse tan of -4 over what? 3. But look at the point, 3 -4, right? And your r is 5. Here, it gives you definitely a negative angle. How to change it to positive? How you can change a negative angle if you are dealing with tangent to positive?
Reflecting it.
If you do what? Trigonometry. I will grade you a trigonometry professor. How you change tangent to a positive angle? You add what?
Reflecting.
You add 2 pi in it, right? It changes to positive. That will be your theta. It's really a tricky point if you want to write this way. People who knows math very well, they know what they're talking about. But for some people, it's like, is this like a coordinates of a point? Yes. If you want to put in a parentheses, you will write this way. 5, comma, inverse tan of -4 over 3 plus 2 pi. That's your coordinates. Next example is a little bit more interesting. Again, r equal 2 sine theta. here I want to talk about converting a polar equation. This is equation, right?
I have a
Convert,
question.
yes.
Can you please mute everybody? Because like there's somebody with, I don't know who it is, but it just keeps interrupting you. It's like distracting.
I can do mute everybody, but I don't want to do that. Can you mute your mics, please? Those of you that it's on. Yeah, because I also hear a lot of noises and it's kind of getting difficult if you don't mute. Please mute your mic when you are not talking to me. When you talk with me, turn it on. Okay, now we are talking about converting polar equations to Cartesian. How to convert a polar equation to Cartesian. For example, I put this example already for you. They are giving you r equals 2 sine theta. They are asking you, it's a polar equation. Is this a polar equation? First, my question, is this a polar equation? Yes, because I have radius of r and my angle is involved. I have equal sign, then it means it's a polar equation. Now, I want to convert this equation to Cartesian. You know, we have r squared equals x squared plus y squared. And in polar, I know x equals r cosine theta and y equals r sine theta. Now, compare these two equations with each other. I have here r equals 2 sine theta. I have here r squared equals something. To make the left side of these two equations equal to each other, what can I do? Think about.
Plug it in.
No, to just make the right side of equation the same. What can I do with this equation with polar one? Can I multiply both sides by r? Can you multiply both sides of an equation with the same value? Yes. You see, if I multiply both sides of this equation with r, let's see what's happening. R times r gives you what? R squared equals. Here you have 2 sine theta, or you can write it even this way, 2r sine theta. Correct? It means your r squared is 2r sine theta. Look at here, r sine theta. What is r sine theta? What is the name of r sine theta? Y. It means you can substitute, and instead of r sine theta, y. It means you can write here r squared equals 2 times r sine theta means 2y. Understand what I explained here? Now, look at this black equation, which I have r squared equals x squared plus y squared. I'll pick up the value of r squared, which is 2y, and I'll bring it, plug it here. It means I can write 2y equals x squared plus y squared. Is this a Cartesian equation now? Do you see everything becomes in terms of X and Y? There is no R anymore. There is no theta anymore, right? Even I want to show it for you. Even I want to simplify it more. Let's bring everything to one side. X squared plus Y squared minus 2Y equals 0. Agree? Let's do completing a square on the Y part. Then X squared plus Y squared minus 2Y. Who remembers completing a square? How you do completing a square on Y? You take the coefficient of Y, which is 2, you divide by 2, you square it, and you add in both sides of the equation. Remember, take half of B and square and add in both sides from algebra. 2 divided by 2 is 1, 1 square gives you 1. It means I will add 1 here and I will add 1 here. Now, X squared plus, what is this? X squared minus 2Y plus 1. Is this a perfect trinomial? A perfect square trinomial? Yes. Let's write it in factor form. If I write in factor form, it will be a y minus 1 squared. Take the square root of the first, sine from the second, square root of the last term, then a square, equals 1. What is this equation? Which equation is this? Who remembers? X squared plus y minus 1 squared equals 1. Which equation is this?
The equation for a circle.
Equation of a circle. Thank you. This is the equation of a circle. If I ask you how much is the center, can you tell me the center? How much is the center? Your center was H and K, right? Opposite H, opposite K. You don't have H, it means your H is 0. Opposite K, it means 1. This is a circle that's at the center of 0, 1, and the radius of the circle is what? 1. Actually, the polar equation that we start with, r equal to sine theta, it's a equation of a circle in polar system. Correct? Always how to deal? Always first start to change this side of the equation to r squared. As soon as you do that, you can see your r sine theta or r cosine theta on this side. Substitute it to x, change it to x or y. Then plug in terms of y or x here. Correct? And you can change a polar equation to a Cartesian equation. This is all about this part of your lecture, which was the polar coordinates. Next day, I will graph some polar equations. We will start graphing. Their graphs are really, really beautiful. I like them. They have really beautiful graphs. We will start graphing some polar equations. And after that, we go and start the calculus of the polar equation or polar coordinates. Correct? Any question for me?
No, not for me. No.
None.
None? I didn't post yet your study guide. but hopefully it's really, I don't know why I didn't post. Only 2 problems less. I will add those 2 problems and I will post for you. Maybe next week we do also a test, not this week, next week. And that will be our final test. And after that, we are done. I think 2 more quizzes and we will wait for our final.
All right.
Any question for me?
Next week, do you plan on like Wednesday, Friday,
I will
Monday?
give you like 2-3 days. Yeah, I will open the test for 3 days and also like for 3 hours, anytime that you can do. Yeah.
Okay.
But before that, definitely I will review it with you, right? I'll review your study guide with you.
Okay.
Mhm. Any other question for me? No? Okay, I'll stop recording now.